corporate finance practice problem using Onenote. Find bond rate or yield, this time the bond having semi-annual payments, making it a bit more complex than simply having the annual payments. Get ready, it's time to take your chance with corporate finance. Here we are in Onenote. If you have access to Onenote and would like to follow along, you're not required to, but if would like to, we're going to be in the icon on the left-hand side. We're in the practice problems area, then down in the 1030 find bond market rate or yield semi-annual tab. Also note that when using Onenote, you might want to take a look at the immersive reader. Many of our presentations up top will also be down here in the text area. Same number, same name. The text area items having transcripts that can be translated into multiple different languages and either listened to or read in those multiple different languages, thereby being a good complement to the presentations. Closing the tab up top, we have our information, then we're going to go through the calculation of that information down below. We've seen a similar problem to this in the past, but we have the added level of complexity here, this being the semi-annual bond payments. So we're looking for the annual yield when the bond has semi-annual payments, that adding a bit of complexity. So we have the information up top, we have the bonds outstanding, par value 1,500% of the bonds, 8%, and then the maturity in years is going to be 6 years, but the payments are now semi-annual as opposed to annual payments. Now, instead of us then having the market or yield then to figure the price, we now have the selling price, and we want to back into then the market rate or the yield calculation, something that you would think would be fairly easy to do, but because we have two components of this calculation, basically two annuity calculations to come up with the price when we have the market rate, it's a little bit more complex to do that mathematically. So we want to approach this in theory and think about, okay, how could we approach this type of problem and simplify it? So first, let's think about what would happen if we had the market rate or yield and we're trying to figure out the price down here. We would then be taking the present value of the annuity, which would be the 1,500 times the 8%, divided by 2 because it's semi-annual, and then it would be an annuity for not 6 periods but 12 6-month periods, and we would be present valuing that using the present value of an annuity calculation. And note the rate down here is going to be a component, even though this would be the semi-annual rate, that would be the component down here typically in our calculation. Then we would have the present value of 1 for the par value or the maturity amount of the item, which would be the 1,005. We would be present valuing all the way back for the, in this case, 12 periods, 6 years times 2, because semi-annual payments at the rate of 4%, 8 divided by 2, given the fact that it's semi-annual payments. The rate then down here in this calculation as well, although once again it being in essence the semi-annual rate that we're calculating. So that's how, and then we'd have to add those together and we'd get to the price. So now we're given the price and we want to get to this unknown being the rate, which is a little complex given the fact that we have these two different formulas. So we could do that algebraically, but it's a little bit more complex to do that. We can think about it intuitively in terms of how can we do this and use something like Excel to basically pick up this number. Now, one, we have a function that we can use that we'll get down to shortly after this. But two, and might be easier or even more intuitive, is to use the goal seek kind of feature to figure this out. So what we'll do is algebraically, you got to think, well, if I'm going to add those two together, you'd think there's only kind of one unknown there. So I should be able to figure that out kind of algebraically. You can, but instead of us reworking this algebraically, let's do the same format, the same layout that we're used to, and then use goal seek to back into the unknown, which is going to be the rate that we're considering. So let's do that down here. It's a little bit more complex because of the semi-annual payments, but you can imagine this if I did this calculation, if I did this calculation for the annuity and then this calculation and then added them together, assuming some rate like 5%, and then I change the rate of the 5% until the end result gets to what I need it to be, the 1,130, using in essence kind of brute force calculation to then find the answer. Instead of doing the algebra, we're just going to use brute force and change the unknown, which we first assumed, to find it. Now, if we did that, of course, by hand with a calculator, calculating these two out, that would be very long and tedious of a task. But with Excel, we can use the same concept down here and use the goal seek to basically do it. So let's imagine we're going to then do our normal calculation using the present value of an annuity function in Excel, present value of one function in Excel, and then add them together. But we don't know what the rate is, so we're just going to start off making up a rate, which we're going to assume is 5%, and then we will go back in and adjust that rate using goal seek so that Excel will force this rate using just brute force to figure out what it needs to be to get to our end result of the 1,130. That allows us to kind of do the algebraic concept of solving for the unknown, even though we have kind of this complex situation with two equations that are being involved that have that same unknown in it. So let's do this. We're going to say, let's calculate the present value of an annuity with that 5%. It's a little bit more complex, as we can see down here, because of the semi-annual payments. We're going to take the rate, which would be that 5%, but we're going to consider that the yearly rate divided by 2, and then comma. And by the way, if you want to see this in Excel and work through this in Excel, then we do have this in Excel too. You can check it out there as well. So then comma, we have the number of periods, which would be, you could see it's something times 2, which is going to be that 6, which would be annual times 2, and then comma. And then we have the payment, which is this item here, which is multiplied together because we're taking the 1,500 times the rate on the bond, which would be the 8%, but that would be the yearly rate, then divided by 2. So putting all that together, we get the 615.47. Then the present value of 1 calculation would look something like this. We'd have the present value of 1 pulling back then this 1,500 back to the current time period. That would be the rate, which we're going to assume is 5% divided by 2, because this 5% is the yearly rate divided by 2 would be the 6-month rate, comma, number of periods, which is going to be the 6 times 2, or 12. So this multiplication represents that, comma, comma. The future value then is simply that 1,500, the par value. That then gets us to the 1,115.33 if we assume the rate at the 5% for the market rate. Adding the 615.47 to the 1,115.33, we get the 1,730.80. Now, all this is linked together. If we have this all kind of linked together, then we could say, okay, I know that end result needs to be 1,130. I would like to change this rate then until we get to this end result to be what it needs to be. Now, we could do that manually, or we could simply tell Excel, if we're using Excel, to do that. We could say, hey, look, Excel, change this ending number right there to be 1,130, which is what we know it needs to be, by changing the rate, this 5%, which is involved in these two calculations, in the rate on these two calculations. And because it's all connected, Excel can do that with brute force and then just figure out, and in this case, that would be the 1425. So they picked up then the 1425 as the rate. If you do the same calculation here for the present value of the annuity, present value of 1, with the 1425 to double check it, you'd then get to the end result of the 1,130. That's kind of the more intuitive way to do this, because we're used to this calculation of calculating the price or value of the bond, assuming knowing the market rate. Now, you can also do this with a rate function, and this time we'll actually look at the function here. So if I had the rate function, looks like this. This one is useful to do, but also note that even after you do this, I would still recheck it by doing your normal calculation. Once you find the rate, in other words, normal calculation of the present value and the present value of 1, and then double check it using the rate that you would find with this rate function. So this would be the most direct way to do it. This time I'm just going to look at the dialog box that you could see, and then we'll look at the actual calculation with our normal kind of calculation down here if we were to use Excel that way. So we got the number of periods. Now the number of periods would then be the 6 times 2. So the 6 times 2. And then notice here I have to put a negative to make this work. This is why the dialog box is actually quite good here, because that'll allow you to see what the end result will be down here as you enter it into the dialog box, which you can't see so easily this way. That'll allow you to then put the negative signs where they need to be. You do need to be careful with the negative signs to make this work properly. You need a negative sign on the payment, the idea being the payment basically going out. And then the present value would then be the 1,130 130, because that's the price or the present value. And then the future value, which again needs to be negative, would be the rate or the maturity value, the 1,500 in our case. And that will give you the result down here, 7.13. However, note that that 7.13 is picking up the rate based on the periods that are covered, the semi-annual periods, meaning the 6-month periods. So if you want to get the annual rate, you got to take that result and multiply it times 2 to get to our result up top, which is that 14.25. This is why, even though this is the most direct method to use, I would still basically plug it back into our normal process, calculating the price based on the market rate to double check that you are indeed getting the proper rate that will get you to that end result. So you can also see it this way. This is the dialog box up top. You can see it this way, which would be equals the rate. And then you got the number of periods, which would be the number of periods, that 6 times 2, or 6 times 2, comma. We've got the negative here. This would be the payment. The payment would be the 1,500 times 8% divided by 2. So the payment is negative this times this divided by 2. And then the present value is going to be the price, 1,130, positive, and then comma, and then we need the future value, which would be a negative number of the 1,005. In our case, once again, that gives us the 7.13%, which would be the rate for the number of periods that we're looking at, which is 6-month periods, half a year, semi-annual. Taking that 7.13, multiplying it times 2 gives us the 14.25. Gives us that then directly. Notice, however, this is still a fairly complex calculation. And also note that if you didn't double it, if you get something that doesn't look right, you could check it a couple different ways. One, I would highly recommend plugging it back into our normal kind of calculation to figure the price. And two, you could kind of have an idea of what the result will be. Meaning, if I'm looking at this at a 8%, and the price is 1,130, that means that these bonds were issued at a discount. These bonds are currently at a discount at this point in time. And if they're at a discount, then we would imagine that the rate on the market must be something greater than the 8%, so that people would have they can get similar bonds and get a higher rate, and therefore force this bonds to be sold at something less than the par value. That's why it's sold at less. Therefore, we would expect the rate to be something greater than 8%. And for example, if I left this at the 7.13, I'd say, hey, that doesn't look right, because that's less than the 8%. And I can kind of intuitively know that something is off there, right? So that's one way that you kind of want to have an idea of what's going on here. And then if I double it, 14.25, that kind of makes sense. It's something higher than the 8%, which is what I would expect, because if the market rate is higher than the rate on the bond, then you would expect then the bonds would have to be sold at a discount, which indeed they are. And then, of course, you want to double check this, taking this 14.25 and doing your normal calculation with the present value of the annuity, using that 14.25, present value of 1 calculation using the 14.25, and adding those together to double check that your answer then matches what you put into the feed for that 1,130 selling price. We do have this in Excel. If you want to check this out and do the calculation within Excel, you can do so.